Hi, thanks for watching this video on the 6502 simulator and 6502 assembly. And so this is actually the Windows version, although you don't really need to know this, but just for completeness, I'm actually running it under Linux, but using the Wine kind of Windows program emulator under Linux. But that's just a little bit of extra. So I'm in Linux, I've run Wine, and I've run a program called 6502.exe, which emulates the 6502 processor. So this is the program itself. So it's 6502 macro assembler and a simulator. And now I found that website doesn't work, but if you Google, you've got Michael Kowalski and 6502, although I put the E in, I think that actually isn't an E, but it looks like, now it's ages since I actually downloaded it, so I'm assuming that this one under GitHub, you've got a 6502.exe, so I'm assuming that that's the same one that I've got. If you were to go to that link on GitHub, that's if you wanted to get it, although there will be other simulators as well, but that's just the particular one that I'm using. Now this program, so I'm running this emulator. Now the program got loaded in. This is the same program as I did a video on a few days ago on printing squares from numbers 1 to 14, but using the difference between squares equals 2n plus 1. So it starts off loading a square of what's 1, setting n to 0, we're printing the square of 1, which is 1, then incrementing n to 1, then calculating the new difference, 2n plus 1, then adding the difference to the existing square. So I've got the 2 plus 1, 2 times 1 plus 1 is 3, so the new square will be 4, and then so on. So I'm doing this using the 6502 assembly. Now what to do with this first set of, well, I've obviously edited the comments to say display squares using the difference equals 2n plus 1 rule, 6502 assembly. Now this bit here, where it gives numerical definitions for the commands for input and output, I just copy that between programs because it's like a bit like a template. So this is really what comes just from every program as I copy it down. So what I've done in this program, obviously using the A accumulator, well, you've only got the A accumulator on 6502, and then you've got, it's got index registers X and Y, but I only use X. And what I've done here, I've declared 3 variables, well, dynamic variables. Well, there's sort of 3 dynamic variables that I use in all the calculations, and then another 3 which I use in terms of displaying the number. So the n starts off at 0 because I increment it before doing the operations. The difference is 0 because the difference every time will be 2n plus 1. And then the square itself, I initialize that just as 1. So the t and the u then, those are basically just arrays in memory. And then when the index x, when it sort of moves up to the new square value, it will just index t and u to display the correct sort of number. And initially, in the first stage, when all the squares are less than 100, it'll just print the leading 0 for the hundreds. And then when it gets to 100 and over, we start then printing the numbers over 100. And what we actually do in that, when you come to 100, it's a special case, so we'll just print 100. Now for squares more than 100, so it's like it'll be starting at 121 and then 144, etc. What we actually do is we subtract 100 from that number, and then we just print what we've got in terms of tens and units, but because the 100 will have been flipped, the h will be flipped to 1, it'll be 100 with a 100 digit, and then basically the number we get as we use the index is that square number minus 100. So basically what we're doing, so by the time we come to 121, because it's more than 100, we set the h to 1, so we print the 1, but then we just go basically back to number 21 in terms of indexing, and that's obviously because the limit we can use, I think, for the, is it like 8-bit signed, is 128. So this allows us to go a bit beyond 128 or represent numbers. So this is where we declare the variables. So I'll go to the top of the program. So we start off then in a loop. So we'll be incrementing n from basically 0 up to 14, and then just print the squared each time by calculating 2n plus 1 and adding to the last square. So what we're doing is we're taking the square number initially at 1, load that into the index register, and then we also load it into the accumulator so we can do the comparison. So if it happens to be 0, it's a special case, because if we get it as 0, which happens later, it means then we're actually dealing with what was 100, and we've taken 100 off. So what we want to do is, as a special case, we want to print it as 100. So what we actually do then, we don't want to print it the normal way, we jump to a routine called dot no show. And that's what we do, is we take the next value of n, and then what we do is we're adding it to, we're just kind of getting ready for the next one. It was 100 branch equal if it's 0 to dot no show. What it means, yeah, it means basically we don't want to. What it means actually, because we've got 100, we don't want to print it using the indexed addressing. So no show, basically, it takes us out of printing it according to the index on that array of those numbers t and u, and then the no show, what it means is we're just going to carry on as normal, but because we've found 100, if the n itself is number 10, this is the special case because its square will be 100. So we go to P100, and then the end, which means we're just going to print, basically. We've got a routine called print string, which is defined in that lib.65s, what print string does, and then the string 100. So this is a special case where we print 100 and end 3. So that's a special case, but most of the time we won't be using that. And that's then just pushing it. PLA, that's getting it back from the stack, because when you do that, we want to save accumulate A to the stack, print 100, and then get it back from the stack. But going back to the top of the loop then, in most cases what we're doing is, because we're not on 100, we're loading, we want to print the hundreds column, and at the beginning it's just going to be 0, because it's going to be because we're less than 100. Then what we do is we then take the tens array, put whatever the number x is, because the square number then gets loaded into the index, and that's what we use to offset the t and the u, so we can display the 2 digits after the hundreds. So the t with the x, the array t, which is indexed by x, we then put it into the A accumulator. So when we say I want to then call the routine IOPUT C, whatever's in the A accumulator will be printed out as a character, and that'll be the correct tens value for whatever the square is, indexed via x, and we do the same thing for the units. And then we're just going to load in a comma just to actually delimit so we can distinguish between the different square numbers. So this is what so then after we've displayed a square number, we want to, so my phone's just thrown a bit of a wobbler. Want to just, I'll just have to stop here. Hi, so I've had to just restart my phone because my phone was getting full, so I've just taken that video off that I've done and I've just started another video and I'll link them both together. So I think where I was, n is the base number, so we see we're adding 1 onto it. So how we do that, we then just load that number into the accumulator, add 1 just to the accumulator, push it back onto n to give it the new value of n. And then what we're doing is we are sort of saving the accumulator again just to the stack. And then we were doing what we've looked at a minute ago. We were just seeing if it's a special case, which is for 10, and then you've got to kind of just print out 100 sort of verbatim. And then now what we do is we've got a back, because you wanted to just remember what a was, that it was n. And now when we say, so a at the moment has got n. Now when you say ASL, that's a left shift. So basically what we're doing is what's in the accumulator A is now going to be doubled because you've shifted 1 to the left. So we've got basically 2A, which is 2n. And then adding number 1 to it is 2n plus 1. So then we store that to the difference. So the difference is now, via the accumulator, the difference is now 2n plus 1. Now what we want to do is, we then get the last value of the square, push it back into load it into the accumulator, then add the difference to give us the new square. So at the moment, when you say ADC diff, that's going into the accumulator. So the accumulator's now got the old square value plus the diff, which is 2n plus 1. We now store that into the new value of the square. Now what we do is, because we're getting ready, if you've got numbers over 100, compare with 99, and if it's 100 or over, what we do is we jump to a routine called sub 100, because we only do this for 100 and over. And what we do, we then subtract it's like sometimes when you've got to like kind of set the carry flag quite often for subtracting. So we subtract from the accumulator the value 100 and then put it into the square. So the square, basically, it was the old square, but with 100 taken off. And then we compensate for that because it means we'll be going 100 or so less in what would have been in our array for printing out the tens and the units. But we're compensating for that because now we're going to print out the 1 for the hundreds. So the HN, that's the hundreds column. And then what we do is we get n back into the accumulator and then we compare it to 14. So if we've just done number 14, or if it's more than 4, let's it be minus, compare with 14. You know, I think we're saying is if it's BMI.loop means if it's less than 14, what happens? We go back to loop. It's like branch of minus, so it means then that n, if n's less than 14, go back to the beginning of the loop and start again where we print the square. And then if it's not minus, it means we've just done 14, and then we can come out of it. So at this point then we should have done all the squares from 1 to 14. So what we'll do is, let's see what happens then. So in this emulator, I've just been actually running it, but what in the emulator, when you click this icon, you've got assemble. So it's saying assemble stops running, because I was just running it just to check it all out. Stops running, so I want to exit the debugger to assemble a program That's yes, so it's assembled. And then this is like the debugger to debug it, and this is the window where I can see it actually run. And then when I click, this is just basically going to run the program. So you can see it's printed out, so it prints them out in terms of hundreds, tens, and units. 149. So the 100 there, 100 there, that's the special case 100. And then from this point on, what we've actually done is, because we've had our first number after the 100, it actually worked out, it actually evaluated to 121. So what we did was then we subtracted 100. So the 2 and the 1, that's actually indexing 21 in the tens and the columns. So it's bumped it back to 21, but we've compensated for that by setting the H to 1. Now, had it been, so we've got to do it at this point, because see 144, that's more than the 8-bit unsigned would allow us to have. So basically what this really is because we've gone back to 21, we've then basically taken because the difference between 121 and 144, it's the same as between 21 and 44, which would have been your 2n plus 1. That's right, because n would have been 11 here, and then so the difference would have been 23. So basically, it's going from a square of 21 to 44, using the difference, then 44 to 69, and then 69 to 96. But because we've flagged, we've now set h to 1. We're now printing them as 100. So I hope you've enjoyed this video, and it makes sense, all of this. And I've quite enjoyed using the 6502 simulator. Okay, so thanks for watching this program and this video. Okay, and goodbye.